Hello everyone and welcome back to this video on the TheCodeBakery. So in this video I'm going to be solving this problem, which is the August LeetCode challenge, which is day, I think, 12. Yeah, day 12, called Pascal's Triangle 2. So I haven't read this problem yet and I haven't tried this problem, but I'm going to be solving this problem live so that you guys can see my thought process. So let's just get right into the problem. So given an integer row index, return the row indexed row of the Pascal's triangle. Notice that the row index starts from 0. Okay, in Pascal's triangle, each number is the sum of the two numbers directly above it. So could you optimize your algorithm to use only OK extra space? Oh. Okay, so the statement is essentially asking, can you do this problem without essentially rebooting in the entire Pascal's triangle? Okay, so one important thing to know about Pascal's triangle is that it follows this like pattern. So it's like 0 choose 0 is the 0th row, 1 choose 0 is the first row, and 1 choose 1. So if you're good at math, or if you've done like any math competitions, you probably already know this about Pascal's triangle. And if you don't, I'm sorry, I really kind of forgot the proof for how this works, but I'm sure that if you go to Google or something and search up this proof, you'll find many results because this isn't too obscure. But Pascal's triangle essentially follows this, where it's like the ith row, choose, and then whatever index it is currently at. So we can essentially use this to find out the entire Pascal's triangle, or which element would go with which, and this would only use a constant amount of space. Okay, so let's just create a method to do n choose r. So it's int n choose r, int n, int r. And I don't think that we can just because n choose r is essentially n factorial over r factorial over n minus r factorial, like that. However, I don't think that we can just do this formula because we might run into an int overflow, or even a long overflow if we're using the max, which is in this case 40. So you probably have to optimize it a little bit. And here's I don't know if you can optimize this more, you probably can, but here's a neat optimization, because we know that n factorial and whichever one of these larger ones will cancel out. So it's essentially n times n minus 1 times n minus 2, and then r factorial over here. So we can essentially use this optimization. So we would first have our answer to be 1, and then we would say for int I equals to 1, I is less than or equal to r I plus plus. Or actually we would have, yeah, because I want to kind of optimize this, so it would be r is equal to the min of r and n minus r. And that's another thing about this, is that n choose r will essentially is kind of a cycle where 3 choose 1 is the same as 3 choose 2, 2 choose 0 is the same as 2 choose 2, and you can see this essentially in the formula, because it's for example, 3 choose 1 is 1 factorial and 2 factorial here, and 3 choose 2 is 2 factorial and 1 factorial here. So yeah, it will cycle, or repeat. So I want to have the minimum number of times in the denominator, and then I'll say answer times equals to n minus I plus 1, I think, and then I just divide it by I. And I'm pretty sure you can just return an answer here. And now we would essentially have our vector of the Pascal's triangle, and then we would say I is less than or equal to row index I plus plus, and we just push back and choose our row index comma I. And we could even optimize this, I guess, even more by saying, so we have like a map, and we'll just call this like that, and just our answers, and then we would say, we would just store this, so we essentially only have to do half of the things, so r is equal to ans, and then I would say if and then I can just return our vector. And I think that this should work. Yeah, so I don't think that we should run into like any int overflow errors or something like that. Oh, turns out we do. Okay. Well, okay, then let's just do a long here. And I really don't think that the other places should have any overflows though. Okay, let's try to submit that. Yeah, okay, accepted. So this problem is actually like pretty math heavy, and if you aren't very familiar with these concepts, they might be difficult to you. But with a little bit of like thinking, this problem isn't very too difficult. So I hope that you guys enjoy this video, and I'll provide this solution in the description below. And I hope that you guys can watch other videos on the Code Bakery. And thank you and goodbye.